Goedemiddag. My name is Shawn Wildermuth. So I'm a long-time at Microsoft MVP. I'm a Docker captain, etc. Some of you may have seen me on YouTube or Pluralsight or at a bunch of conferences over here. I now live in the Netherlands, in Den Haag, and your country's been very welcoming to us. So just wanted to thank you for that. So I wanted to start by talking about architecture. Before I do, can I get a raise of hands of people who consider themselves architects? A couple. Raise a hand of people who would like to be an architect? A few more. You're very shy, aren't you, as people in the hall? You'll be very blunt to my face, one-to-one, but you get in a room, they're very shy. So my experience with architecture is that you go to a place like a conference like this and you get thrown around a lot of things that you're being told are the way of the future. This is the next big thing. This is how you build applications. And in some sense, the idea would be that if you don't follow our prescription of what technologies to use, that you're doing it wrong, that you're not going to scale, that you're going to fail. And I have a real problem with this because most of us build very different applications. And so having a prescriptive one-size-fits-all or one approach fits all has never worked for me. Most of the clients I work with are doing very specific things. You know, working with a website that has 1 million visitors a day, that's one set of architecture that's important to me. But I've worked with a company that delivers trucks, and they have about 12 visitors a day to their application. Just as important and just as crucial to their revenue so that they can pay their developers, but understanding the great differences between them. 1 million users a day that have 3 small data changes, 12 users a day that send you a gig of information. Like, those are very different kinds of applications to talk about. So before I start getting into some of the suggestions or the ways that I'd like to see if you would embrace, I want us to sort of back up and talk about the history. Because most of what we're building today is distributed computing, whether we know it or not. You know, an API server is across a wire, so it's distributed, whether that's the browser to the API to the database, whatever it is. And early in development, you had a computer. Took a whole room, lots of tubes, and you programmed it by just using cables, right? There was a sort of a magic, and then they used lights to see what the results were. We're not doing that anymore, right? It's not 1947. And these, the big bonus then was we can program these now with punch cards, so they could have you put in punch card instructions and it would then print out something. There was still no way to actively interact with these systems until soon after that. And this is where, like, the first of our programming sort of started, but it was still just a monolithic computing. You fed in stuff, you got stuff out, and you hoped it was right. Hoped that, a literal bug wasn't somewhere in the tubing that caused the problem. And early in my career, we were doing a lot of what was called client-server, which was really writing stuff for a computer that talked directly to some database. That was the extent of client-server. And this maturated quickly to having a middle tier, 3-tier development that did a lot of the work, offloaded a lot of the work, worried about security, et cetera. And these were attempts to sort of scale up the amounts of things you could do, and it was difficult. You started to see N-tier, which is everyone gets their own box to do their own special thing, but we're still passing along data across it. It isn't the way that we think of, like, microservices today. We quickly, when the internet sort of came in as a viable business platform, people said, okay, I'll put it up in the cloud. I'm not talking about Azure. I'm talking about putting physical boxes in data centers, right? This is a lot of what happened in the early 2000s, mid 2000s, and then of course where we're at today is that everything has to be a microservice, everything has to be containerized, and everyone gets their own database now, right? And the problem with this is that none of these sort of changes in the way we do distributed applications applied to everything. But there was a vested interest in certain people to say this is the one and true way to do this. And when you hear of a new way to do things, I want you to be suspicious, not of their motives, but of what's going to happen in 3 years when people start using this and figure out what the right use cases are, right? Because Microsoft certainly guilty of this, of like, ooh, look at the new shiny thing. We should do all of that, and we're going to stop supporting the old stuff. Hopefully, we're past that point in Microsoft, but that was a big issue with them for a long, long time. So let's talk about what architecture is. I'm talking about software architecture less than hardware architecture. At its base level, it's how do different components interact. Whether that's components on the client, whether that's somewhere inside your server mechanism, whether that's inside of a data store. And for a long time, we could assume that these components were local, but not anymore. We need to understand that we're really just talking about how they interact over a wire often. And it's important to know that when you build a system, if you haven't designed an architecture, you still have an architecture, right? Whether you started building a house by just hammering wood together or you had a plan, you still have an architecture for the house. Doesn't mean it's wrong or bad or needs to be raised into the ground, but you still have it. And so understanding what that architecture is and where it and what the pros and cons are is a big deal, a big part of what you as software developers do. You're trying to make software be more reliant, more capable. And what it comes down to is I feel like for the most part, most developers are a little insecure about that they're doing the right thing. And so they look to people talking about what they think is the right thing. And that's not always the best thing because no one knows your particular business. So while architecture is important, there's a bunch of different sort of pieces about this. So scalability, every project I've worked on since 1986 has always had a bullet point, make sure it's scalable. And I'm like, well, what do you mean? That is as unprecise as possible. And scalability, especially these days, is easier to think about. Oh, Azure or whatever cloud allows me to create 2 or 3 or 5 or 100 instances. That's my scalability story, right? One, that shouldn't be your scalability story, right? Understanding how things scale is important, but scalability just doesn't mean scaling CPU out, which is all that really does. And not every application needs that sense of scalability. You need to know what your constraints are. If you have a low number of users, but processes need to be super fast, scalability isn't as important as having processes that run really, really fast. And that may be a few large systems instead of 100 small systems, right? You need to figure out what what is going to actually serve the solution. For most of us, it's a business of some sort. I want to sell more widgets. I want to provide more services. I want to make sure that the train schedules are correct. All of that ends up being important to what you think about architecture. But these other requirements are important too. Availability. So what happens when something goes down? Maintainability. Is this an architecture? Is this a code base that we can add to and change and fix? Because you can very easily get into a code base that is hard and terse. And it doesn't matter how new your code is, that's going to always be true. A lot of times we think about legacy code as being spaghetti and hard to manage and stuff, but you can do the same bad things in Visual Studio or Visual Studio Code, JavaScript or C#, or you can write bad code anywhere. I mean, that's really the freedom of software development, is you can be bad everywhere, right? Resilience, and then of course cost. Cost used to not be as much of an issue because we all thought we would have the 2 PCs sitting in a data center, but now we're using cloud services, cost becomes more important. You don't want to be surprised, oh, if I scale this up to 10 systems, how much is that really going to cost me? Or if I scale it up to add more cores or make them hot all the time, those are real costs that you have to think about and maybe part of that architecture. Because ultimately, most of the stuff we build needs to pay for itself, right? And if running a system, this happens in startups all the time. They're like, it's going to be easy. I'm going to throw it in the cloud. I'll get 3 interns to write it, and it'll be great. And they put it up there. And they're like, why is it crashing all the time? Well, you didn't plan for anything. You just sort of made it, because that's the nature of startups. That's not negative on startups, but to get an idea out in front and know that that's what you're doing. So what it comes down to for me is it's important for me to have what we're going to do architecturally written down somewhere. Doesn't mean it has to be, you know, a 100-page document that talks about every permutation, but have a plan down on paper or a PDF, if you prefer, I don't know, Confluence. Because what often happens is we get stuck into this place of being so worried about architecture and being so worried about what the experts would think of our architecture that we try to strive for this perfection, try to strive for these things that frankly aren't important to maybe your situation. Trust yourselves is a big part of this. Like, nothing that we do today can't be changed tomorrow as well. So try, prototype, test. Like, don't be afraid to do these things. Because if the people you're working with, you're afraid to be found out as you don't know everything you need to know, that just poisons the whole system. We all feel like that at some point. We all feel like that. I was coming up on the train and I'm like, you know, I really don't get MCPs yet, you know? But there's this part of me is like, I should know everything. Well, like, I can't. I have to pick my battles, pick the things that are important to me. And when it comes to architecture, every time I work with a new company, it's less about what technology you're using than it is, what is your business? What is your goals? What are you trying to accomplish here? What are you trying to accomplish that you can't do anymore? One client I'm working with is moving from a VB6 app. So it's very clear he wants the developer that maintains it retired 2 years ago and is still working part-time. So he has a very clear reason for wanting to change the application, is that those people don't exist anymore and they're worried this guy's gonna get hit by a bus, right? Or a tram, I should say, over here, right? So don't worry about making mistakes, because a lot of what you're building, it matters what the context is. In a large enterprise, if you're building something so that the people in one department can record when their vacations are going to be, and of course everyone here just puts August, right? Just all of August. You need to understand what that's for. Is it forms over data? Are you processing data? Are you trying to get money directly from consumers? Are you building transactional systems where the safety of that data is crucial? And so ultimately, by knowing what you're building, there is learned behavior by seeing what other people are building. But what I find too often is that we're comparing what we do to what we see is available and out there. Well, if Facebook can do it, why shouldn't we? Well, they have a little bit more money than we do, a few more developers than we do. Not better developers than we have, but more matters in a lot of these cases. So this is where I come up with this idea of the right-sized architecture. Often what happens is we're so concerned with architecture that we prematurely try to create something that's super, super flexible, even though that's not going to serve our product. Focusing on these real requirements like I talked about earlier is a key to this, is that having one web server and one database when you start an application is fine, knowing that you're going to figure out where the pain points are, etc. And understand what is good enough. This happens a lot in the REST space. People are like, I'm using REST, but it's just RESTful. It's not perfect REST. It's not, like, it doesn't matter. Is it working? Then, no one's going to come and check your work. You can't plan for everything. You're going to find situations where the architecture is like, oh, this isn't going to fit because of X, Y, or Z. And that's part of our job. That's probably why AI won't take over all of our jobs. Because this stuff and understanding our code base and understanding your architecture is crucial, because you're going to be surprised. And more often, that surprise isn't technical, right? Your boss comes in, they've sold a new customer, and the only way they got that contract sold is because they have to add this feature. And you can't put it in the backlog because they need to sign the contract. Like, that's, you can't have known that that was crucial. But I also like to get paid, so when the sales people say they sold a new customer, I have to understand where my money's coming from. And just like you do with code, iterate your architectural designs. This is crucial to me, is that we think about that we're pouring a slab of concrete and that it's there fixed, and then all the software is just on the slab of concrete. And that's just not the case. We have the ability to change these things as we go forward. Scaling is the word I want to use, but growing up with your application means that things are going to change, whether they're large architectural things or small things, how you're hosting it, whatever it is, those are going to change. So how many here work for Netflix? I have a movie to pitch, I have to ask every time. Netflix is very open about their architecture and their goals and how they do things. And what happens is that's what a lot of developers hear, is we need to be as distributed as Netflix. None of us do anything in the amount of data that Netflix does, right? It's a very specific use case. When you're building the pizza shop and you're trying to use the architecture from Netflix, you've got a problem. And this is what I'm seeing a lot. I go into organizations like, we're using Kubernetes, we've built a microservice, and I said, aren't you just delivering pizzas to people's door? Like, what are you doing? Well, what if it goes down? Then you write down the order, you still deliver the pizzas. Like this, there's easier ways to think about this in the big picture. And in the same way, when we think about the nouns that we're asked to build, when I say, I need to build a house, all of you have a picture of that house, right? It may look like an apartment. It may look like an actual house. It may look like a wooden structure somewhere in the US West or somewhere in Asia. And in the Philippines, it might look different. All these are valid houses, right? For where they live, where they're constructed, you know? You wouldn't build the third one here in the middle of a city. You wouldn't build the apartment block in the middle of the Thai countryside, right? They just don't make sense. And so I'm not saying you shouldn't learn from other people and other architectures, but I am saying knowing the domain is the most important thing. You know, when people talk about retention in companies, they're like, well, what if my skills get old? We're going to lose people because they don't want to work in X, Y, or Z anymore. And we don't really want to train them because they'll just leave. But the most valuable thing we provide to a company is understanding how their company runs. Because it doesn't matter where the if statements go, whether you're using tabs or spaces. None of that matters if you don't know what you're trying to solve. the language of each business is a little bit different. This is talked about a lot in domain-driven design, but it's still the same problem in architecture, is knowing is more important. So here we come to the small, insignificant microservice and container talk. I think for a lot of organizations, they think that microservices and containerization are the same thing. That they think that I'm building containers, therefore each container needs to scale on its own. We need to have this subsystem, we need service discovery, we need all these things that most applications don't need. So I'm very pro containerizing, mostly for repeatability, but that doesn't mean I'm necessarily going to throw it in Azure Container Storage or in a Kubernetes cluster. They're important in a lot of cases, but I feel like I'm beating the same drum over and over again, but know your business. Ultimately, you're going to want to treat architecture like you do code. Design, implement, observe, and I'll talk about observe in a minute, collect, and then refine that architecture. Now, the observe and collect are about monitoring, because if you don't have monitoring of your system, you don't know if there's issues with your architecture, just like you don't with your code, right? The kind of monitoring you're doing here isn't throwing errors. Monitoring here is throughput. Is the number of users we built it for really the number of users we have? How long do transactions take? How long do data queries take? Like all of that you need to know so that you can build an architecture that serves that. And you can only do that with data. You can't do it with gut. Doesn't mean you can't build it the first time with gut. But at some point you need to know, is this important enough? Because it's interesting, usually people don't under-engineer an architecture. They almost always over-engineer it, thinking about every possibility that could happen. And as developers, that's kind of our thing, right? We want to solve a problem, and we want to make sure that that problem is solved for good. And that's not really what happens. That gold plating your application because of one user might want this or that is the same problem we have here with architecture, of making it too robust when we just don't have that many users. So this is something from Martin Fowler that validated some of my feelings about this. I won't read this to you. I think most of you can read it. And I think this is interesting because we often go into the situation where we think of legacy code as being bad code. And that we get into these terms of, oh, you're building a monolith, and we hear at conferences that that's a bad thing. Maybe a bad thing, but again, it depends on what you're doing. Building these monolithic systems can impede things, but it doesn't mean you have to go straight to the other side of the monolith. Steve Smith talks a lot about modular monoliths, which is one of my sort of favorite things to suggest to people these days, where you essentially start with a monolith knowing you're going to build it modularly so that you could if you need to. So when you're looking at this, we're often talking about the first iteration of a product. You want to think architecturally as you continue to build the product, as you build new versions and such. This means you have to think architecturally, I think, at some point, not every part of your job, even when you're dealing with legacy systems or code that isn't brand new, you're in the 5th version or whatever it is, you still need to think about these things. Again, I put a lot of the same phrases in over and over again. I really mean it. And when you're thinking about making a change in architecture, test, which really comes from test with collecting observable data, to see whether that actually solves whatever problem you think you're having, So my favorite phrase, almost every time I give a talk, there'll be at least one person that comes up and says, but what is the best practice? And I hate the phrase because it's a fool's errand trying to figure out what it is, especially new technologies. When Aspire came in, I had a lot of people approach me. It's like, what is the best practice for Aspire? I'm like, no one knows. It just came out. What do you mean best practices? Microsoft isn't really sure what they built yet. Until we all use it for a little while, we're not going to know what doesn't work and does work, or if works, right? You cannot apply every good idea to every one of your businesses. There is no cookie cutter. That is why we do what we do, because there isn't any cookie cutter. If it was super repeatable, just make it a microservice, just make it event sourcing, just make it whatever the thing is. AI could probably do it all, but that's just not how software for the most part works. Understanding principles and patterns, knowing what is out there, what have been found to be good ideas to build on and to use, way more important than trying to reach some perfect best practice. For me, shipping the software is the goal. And if we're sitting worrying about minutia of what if it goes down, what if you have a cascading failure, we need to consider those things. But when that is the goal more than shipping the product, I have a problem. You're not trying to get someone to bless your solution. The only thing that blesses solution is customers or users, right? They're going to come in and they're going to find the real problems of the system, which usually aren't architectural, right? It's usually, well, we used to do this process and a button's missing, right? That's the much bigger concern to stop people from doing it. Or in e-commerce of allowing them to buy with the fewest clicks. This is one of the things that happens a lot there. None of that's architectural, really. I mean, some of it could be in the way you separate an email and all that other stuff, but. So what about technical debt? Does anyone have technical debt? Does anyone not have technical debt? I thought there might be a liar here. I'm not that opposed to technical debt. I'm going to say that a lot. Because technical debt in itself can keep you from improving your product, right? It's the friction to moving forward. But often it's a shortcut to a release. Sometimes it has a business decision, sometimes it doesn't. Sometimes people just want to get it out the door, and so they make some shortcuts. The key here is that when you're band-aiding broken systems, you're building up things that have to be addressed, which means you need to deal with the risk versus reward. We can get this out sooner, but are we going to have more problems down the road? Is it worth this to get it out sooner to see whether it's a viable product or whatever the case may be? So you need a plan for technical debt. Don't just say, oh, we can do this really quickly, but make sure it's added immediately to your backlog or whatever system you have for managing this, because it has to be addressed. It's when people think, oh, we can't touch it, that it becomes really toxic. Software ultimately is about meeting a business need or meeting a solution need, but you can't avoid it. You know, most of us or all of us have some amount of technical debt. And some of it is a real issue, and some of it is, you know, we'd really like to make sure all our namespaces are synced together. Like, some of it is just comfort. Why do we have that in 12 assemblies instead of one assembly? Like, there's some technical debt that is just about managing versus business needs. And I talked about that. So this is an important quote for me personally. This is something that I think about a lot, and that is, when you're building and designing things, do something, right? Because the worst thing you can do is get stuck in the, let me try this, let me try this, let me try this. But when you start moving forward, you can fork the road, but if you're not moving, you're not gaining any more information. So in any point when you get to a decision, understand that you might be wrong, maybe probably wrong, right? You've gotten the best minds in your organization to talk about it, to think about it, try to come to some consensus, but ultimately, when you move forward, you have to know that if you're wrong, that's fine. You know, most of our code doesn't compile the first time. It doesn't mean we should never write the code, right? And that's what it feels like in a lot of these architectural decisions. You get caught up with, well, what if I'm wrong? It's fine. It's fine. So I talked a little bit about this, but after you have the design, the implementation of that design isn't the end game. You're like, okay, now we have an architecture, we're fine, because we do need to start iterating. Architecture matures over time, and you have to understand when you need to change. So again, monitoring, I probably should have put this earlier in the slides, but monitoring is crucial. So this is sort of the place where I come to you and say, what's important here is to focus on the business problem and to stop worrying about the dogma. When you read, this is how you're supposed to do it, take it with some suspicion. Because usually, if someone is saying this is the best way to do it, they're selling something. Not necessarily for money, but for clicks, for prestige, whatever it is. All of these, most ideas that are out there are good ideas, but not a good idea for every solution. Questions? I don't know how early or late we're running. Questions?
I had a discussion once with someone who had the statement that the over-engineering, the over part, is really a manly thing. How do you think about that?
So the question was, is the over part of over-engineering a problem with, quote unquote, the manly thing? I don't know if I would put it as the manly thing, but I think there's an instinct as engineers to think through all the permutations and to think, I don't want to get caught up if it's not good enough. I think that's probably, for me, a bigger part of the problem. And I'm not talking from an ivory tower. I spent 20 years doing all of this stupid shit, right? I'm just as guilty as anyone else of doing it. Is only when I realized, oh, you know, I was working with who then was a really big name in software development. And we were sitting down trying to work out a problem. He had done a software startup. And I really looked up to this guy. And I said, well, how do we do da-da-da-da? And he said, well, let's find out, because I don't know. And hearing I don't know from someone you really look up to is eye-opening. Because what it told me was not that he doesn't know everything, but that I don't have to. I don't have to. And that, to me, is critical to that. And so a lot of these over-engineerings, I think, are more about cover your ass, or I don't want to be embarrassed, or if I say it, it has to be true. You know, the louder the voice in the meeting, usually is the most insecure. That's been my experience. Other questions? Did that answer?
Yep.
Oh, we'll go back here.
Shawn, how do you see architecture in a world of coding agents, where you can send up 10 agents on to do something? So is it needed by an overarching super agent or by a human, or how do you see that?
Well, I'm the wrong person to ask. I'm an old guy, and so I've been very resistant to sort of the describe the system. I was talking to someone about this earlier. Oh wait, did I, in case everybody didn't hear, the question was, in this age of agents, do you need like an architectural top agent that's running all the other agents that's building code for you? We're entering a place, because we have these agents that are really, really capable of going back to what I did in the early 90s, which is write specs. Because that's all that these difficult and complex prompts really are, is a list of what the system has to do that we used to hand to developers, now we're handing to an LLM. So I think the real promise here is that the agents are going to build code that we're going to own anyway, right? Doesn't matter whether it came from an agent or someone else. And if those agents are junior programmers, you're going to need to lead it in the right direction. So I don't think we need an agent to tell us because agents are very good at going, oh, I know what you're trying to do here. You're trying to recognize a phone number and I can give you a regular expression. What they're not good at is knowing how many trucks need to go out every month in order to maintain payroll, right? Because those are the things that I think are implicit in the job we do to understand, even if we're using agents. Like, I'm not against using them, but understand that it's not going to understand the domain very well unless it's been built directly for your domain. If you're Ford or you're Philips or Siemens, that's probably possible. But when you're working for a small, medium-sized company, that's never going to be the case. Does that answer your question?
Yeah, the spec first, right? What I understood.
Yeah. Here?
Yeah, in extension of Jasper's question a little bit. How do you manage the over-engineering? Is it just, based on your experience, I'm eager to hear, is it just managing perfectionism?
So the question is, how do you manage over-engineering? It's tough. It's tough because it's more of a people problem than it is a technical problem, right? For me, the over-engineering is sitting down with the people you think that are doing this and really approaching them with why. You know, one of the phrases someone told me, the first or second big conference I ever did, was Richard Campbell said to me, don't worry, you've got the job. You don't have to prove it to us anymore. And that's what I think some of this is. Like, over-engineering either can be, I'm really interested in this minutia, or it could be, I want to impress everybody because I don't think I belong here. And those are two very different things to manage. So unfortunately, I don't have a best practice. No, I don't have a... but to me, over-communication with those people to help understand, to communicate to them why you think it's over-engineered in a peer way. Not like, stop it or you'll get fired, or stop or I'll move you in team. Like, that doesn't work to do it. But to really have that conversation, like, you're working harder than you need to. We know the domain we're in, and we don't need to worry about the bigger and bigger and bigger. But there isn't a magic pill there.
But just to verify, sorry, extended question, it almost feels like managing imposter syndrome the way you're explaining it.
I think some of it is.
Okay.
Yeah. So what he said, in case you didn't hear in the back, it's almost like managing imposter syndrome. And I think that's not untrue. You know, and imposter syndrome isn't a simple thing. Early in my career, I wanted to be the big guy in a small company because it was a safe place for me to be, and no one was going to find out that I didn't really know what I was doing because there weren't a lot of other technical people to question me. Right? That's absolutely my first 5 years in tech. And I sort of, when I started speaking and other things, I sort of got over that. Okay, I do belong, and then 2 years ago, when Pluralsight started to do less and less work, I got it all over again. And it was faster to get rid of this time, but it was still there, like, oh, I'm not one of the cool kids, I'm not maybe, you know, AI is one of those places. I haven't invested like other people are, and so I'm afraid that I don't know what the heck I'm talking about. You know, I haven't implemented 20 MCPs. Does that mean I'm a bad developer? You know, it happens to everyone. That's the important part. This thing ebbs and flows, confidence. I give another talk, since we have time, where I talk about arrogance is usually insecurity. I'm convinced of this. Arrogant people don't want to be challenged, and so being the loudest person in the room or putting down other people is to make sure that they don't get found out. So I think you're right about that.
Thank you.
You've been a great audience. Thank you.